we are very proud to have a presence globally. So we have pretty much covered most of the globe in this case. So we strongly believe in collaborations of genuine collaboration. So definitely internationally look at natural gas, which will have a little bit more detailing today. So there was also there. Also, we are also working, also have a license with BARC and higher engineering technology of ISC Professor Rajan. Also, we are also working with Indian Oil to do more detailing of the technologies for CBG. So basically, the biodigesters, yeah, the biodigesters pretty much decomposition, biogas production, fertilizer, and no accumulation is a common for both the digesters. It may be wet or dry. So these play both fundamentally the same role. So now we'll go to the next slide where we'll be seeing the pretty much a wet digester, which is pretty much very prominent in the sugar industry. So there are many installations everywhere. So where typically the design is designed for 8 to 12% total solids. In the next slide, we'll be seeing the dry digester, which is pretty much designed for almost 25 tons total solids in feed. So I'll just give the comparison, then Rückert will take through the dry digester. So I think it creates a value of what both define. So what's the difference between both? So which is better, which is where it is better, where the other thing is better. So we'll just go through a few slides and then Rückert will join. So if we take a basic 90 pt wet digester plant requirement, so these are the requirement like an average wet digester requires when we are using solids like press mud or Napier. So it will require at least 30 tons of fresh water, which requires to dilute this thing, and there are these three slurry tanks for each digester, which is considered, and total volume of 20 average 7,000 meter cube into 23 3 is almost 23,000 meter cube. So typically, this is how a wet digester looks set up. So let's see in the next slide what happens. So pretty much it is very clean. There is no requirement of water. So there is no requirement of slurry tanks. Now it's just pure two digesters that do just half of the volume, approximately less than half, which is required for a dry digester. So typically, if you say, so we have made a comparison of both the things. So if the for a 910 TPD, you still require a 220 tons uh, approximately of feed, and the main difference you see is the target slurry, and also the recirculation volume is very high. And wet technology, where almost 264 tons is required to recirculation, and that's where more is required. Also, the fresh water of 66 tons is required in wet digester. So that's one thing which is very highly required. You will be able to see where the digester volume is just 6,000 in dry digester, whereas 15,000 in wet digester. That is due to you're adding more and more water to just dilute the digestate and making it use it. So, but many people say that there's a difference of the CBG's generation is same in both. So when you efficiently work with any digester, you go to get the same CBG. Only the water consumption is less. So now there are pros and cons. Of course, dry digester you have less water, no slurry tanks required. So a lot of advantages here. However, it can be used only for substrates having high solids. However, if the solids is very low, then for example, it may be dairy effluent, or it may be spent wash, or it may be pharma effluents, which are 8 to 12%, which requires a wet digester. So they cannot be used in dry digester. So when to use dry digester, when to use wet digester? Of course, the answer is simple. When the solids are high, more than 20-25%, like press mud, poultry litter, Napier gas, it is very well suited for them. However, in wet digester is more suited for spent wash or any diluted. If you want to dilute and use it, then it can be used. But again, the disadvantage of extra water is there. So before I hand over to Claus, we just want to inform, we have already informed that the IoT system or AI based is for both wet and dry has been introduced. So this is the first time we are launching this in front of our audience. So next, I hand over it to Rückert. So he will be taking us through the dry digester component. So most of the elements in the existing plant, which our team is there to show you, have been captured, and Rückert will talk over it, and then Himanshi will show one by one item at a time. So So Claus, before handing over to Claus, Claus is the inventor of this technology, Rückert NatUrgas. He has the European patents for it, and he has done almost 90 projects across the globe with different substrates. So in this project, which we are be seeing is using corn maize, and also they are using the old grass and other substrates, which our team will also be showing it. So Claus, I think you can start off.
Yeah, very warm welcome from my side to everybody. I'm happy to be able to present you some details about our design from biogas for biogas plants, and hopefully you get the difference between wet and dry digester. It's a very old plant we did not 20 years ago, but almost 20 years ago. It's in the northern part of Germany, and you can see the footprint of site. The rectangular digester you can see in the middle of the footprint is about 27 meters long and 50 meters in width. And the net volume is about 2,000 cubic meters. And this plant was actually designed for 600 kilowatt electrical performance. And later on, post digester has been built. So we have 2,000 cubic meter post digester on site. So in total, it's 4,000 cubic meters. And it's possible to generate more than, oh, it's too quick, more than 500 to 600 cubic meters of biogas per hour with this dry digester. As you can see on the right side, there you can see a screw conveyor, and all the substrate we have as a feedstock is brought into the digester in a dry like it is as a dry matter. So stones, metal parts, big wooden parts are not welcome. They block a pump or the screw. So with this digester, we are able to feed the feedstock dry like it is with 20, 30, 40% of dry matter content. And I can give you a small idea why we can do this. It is because of the agitators. We built the digester around the agitators, and as long as they are running, we can homogenize and mix the substrate all together. So we push up sediments and we push down floating parts. And so we mix everything to the sludge inside the digester. Pictures there, you can see where the feedstock is brought in a drive-in silo. So this what you can see is maize silage. It's, I think, my guess it's quite close to Napier grass. And we seal it to avoid oxygen, because we need to store it all over 1 year, because in Germany we have only one season. It's starting now, where maize can be harvested, and then we need to store it for almost 1 year. On this special biogas plant, we have almost 60% of the feedstock is grass, means it's from extensive agriculture fields. It's harvested several times a year, and it's chopped to very small pieces and stored in a silo as well. Here you can see the front end loader filling in the substrate dry like it is to a screw conveyor. And this is very easy to handle. And this is a background why we can run the digester on almost 15, 16% of dry matter content at the end of the digester, means after the bacteria did their work. So we take out the biogas, we take out the carbon, so the dry matter content lowers. And at the end of the digester, we are around 15, 16% dry matter content. This you can only get if you feed dry. If you feed it wet, the pump is limited to 12, might be 14% in the inlet. So it means in the incoming fraction to the incoming substrate to the digester, the bacteria do their work, and outcoming you're only between 6, might be 8%. So you will never get more than 8 or 10% of dry matter content if you feed wet. That's why we save volume. It's not because the bacteria are different. It's not because the working condition for bacteria are different. We do the same job, but we are able to homogenize the content of the digester. After the digester, we have the dewatering. We do it directly directly after the digester, because if the dry matter content increases inside the digester, we give back the liquids after dewatering directly to the digester. So bacteria are still alive, it's still warm, it's still active, and we only take out used substrate. We take it out of the process and store it beside the digester, or we can truck it back to the silo until the time is come to use it as a fertilizer. Here you can see an open lagoon. It's a rectangle, no, it's a tank, not a rectangle, it's a round tank without a cover. In the back you can see a new, it's built last year. It's a 3,000 cubic meter tank to store the liquid fraction after digester. It's a different view. What we do on site, we use the biogas directly to produce electricity and heat. And on this site, we have in total 1,200 kilowatt installed performance for CHP. One CHP is on site. You can see 1,259 kilowatt performance.
So can you convert into raw biogas by any chance, Rückert? Well,
it's around 550 to 600 cubic meters. I'm just looking where it's a flow meter for the gas, but it's a proof. If engine is running, it only can run on gas. It's 100% running on biogas. So you can see one engine is 716, the other is 543. Gas holder is still full, so because it's totally yellow. So about the feedstock, I already told you. Digester volume total 4,000 cubic meters, and raw biogas is almost 600 cubic meters, or 580. It's calculated. And this is plenty of power. There is so I'm doing biogas more than 30 years now, and there's a misunderstanding about the digester. The digester is completely filled. It's a static process. You feed it every hour, you take out substrate every hour, you keep the temperature very close to 45, 47. Most important is you keep it where it is. And bacteria are doing their work 24/7 for you. And the most important thing is that the digester is homogenized, mixed up and homogenized. If you can't make sure that you can do that all over the years, it's not running, you have problems. And if you have problems in a digester, you will not produce gas. And producing gas is the most important thing. So feed them, heat them, and you will get the gas. You don't need to know how it works, but believe me, I didn't knew before, and it worked. I was the luckiest man on world, like burning the first biogas. And we learned about the years how to build a digester, and a digester is good if it has a pump and if it has a mixer. That works.
Thank you, Klaus. Now we will move to the part where we go to the live technology tour. Hi, Himanshi. Everyone, we've got Himanshi from our team who is currently live at the facility. And she's going to take us through the facility along with Klaus Rückert, who is going to also take us through the facility and talk to us about it where necessary. Himanshi, if you can just slowly walk and show everyone present here the facility.
I'm just gonna walk around and show you, and maybe Klaus, if you want to support the video with your explanations that you already did, might be helpful to give everyone a clearer perspective.
Yes, we can. Oh, it's unmuted.
No, we can hear you.
Okay, so we can see the drive-in silo. They're huge. It's because feedstock is around 60 to 70 tons per day, and we can yield around 150 to 220 cubic meter of biogas per ton of feedstock. It depends on dry matter content and the quality. So one of the biggest problems in Germany is the rainfall. If it rains on site, we have plenty of sealed area and we have to catch the water. We can't let it go, and we don't need it in the biogas process. So we have to make sure that we don't pollute the environment. So here you can see the dosing feeder. In former times, we decided to build a building around the dosing feeder, so it's easier to throw in the feedstock with the front end loader. So the operator is able to have a good view inside the dosing feeder. That's why we have a cellar or some ground floor building. And you can see it looks like 20 years old. We have corrosion because of the acids in the feedstock.
They were just filling it.
I'm missing the front end loader. It's gone. It's gone. So you can see this is not.
This one is very at large because this is the main feeding system of the diet digester.
Right.
Mr. Praveen, you have told us that you are pumping the material in digester, but they are having some screw conveyor. They are showing some screw conveyor there. You are on mute. Please unmute.
So the pumping of means basically this is a little bit older version. As Rückert told, this is a 20-year-old site. So the recent versions, what they are doing is to remove the stones. We are washing it. We keep a small 50-meter cube where the overflow comes inside that thing, and then it pumps. So that's a recent advancement which is there and which we are adopting for the new projects.
Himanshu, might be you can go across that along that we can see the screw conveyor.
Yeah. Oh.
To the right, to the right, to the right. Stop, 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 stop. No, it's too far. Yeah, here we go. You know it better than I do.
There's a big box in the middle.
Very nice, yeah. So on the left side, on the left side, we can see the digester. We can see the windows where we can have a look inside. I'm not sure whether it's possible now or the agitator is running now. So it's difficult because it's very bright light outside.
It might be hard, but basically it looks like a lot of mush that's being turned by metal rods, sort of.
I'm sure we can find a small video later. So at the very end, if you go a little bit further, so you can see the screw conveyor. And they feed some grain as well. You can see a small mill, grain mill. It's to push bacteria to produce more. Yep, very good. To produce more biogas. And if the price is low for grain, they buy in grain and convert it to electricity and heat. Some years ago, they used an extra external chopper on site. That's because the screw conveyor doesn't go directly to the digester. It's running in circles. But they decided to chop it while harvesting, it's quicker and it's cheaper. And the conservation in drive-in silo is easier and better from the quality. So you save gas. You don't lose gas while storage. Here you can see the external heat exchanger. We take out substrate from the digester, heat it up, and bring it back to the digester. So it's external. Inside the digester, we only have the agitators, 2 of them, and measurement for temperature and leveling. And rest is bacteria and sludge.
It smells really good here.
So the digester is 27 meters long, 6 meters high, and 15 meters in width. So net volume 2,000 cubic meters. We can build it a little bit bigger, 3,000, 3,500 in a rectangular, and 5,000 to 6,000 in a round digester. So this is a product, dry fertilizer, not really dry. It's 25 to 30% dry matter content, but it looks like a compost. It's called anaerobic compost, and you can use it as fertilizer in the fields or mix it with other kind of material and you sell it as a fertilizer.
You want me to go inside?
Please. So in Germany or Europe, we have cold temperatures in winter and not that warm in summertime. We have lots of rain in different seasons, and that's why we have a pump room. We call it pumping room, to keep system warm, avoid frost, problems with frost. And here you can see the drives from the agitators. It's 18.5 kilowatt hours performance, and run the speed in circle is 5 UP per minute. So if you walk a little bit to the side, we can see the other agitator drive in the back, the green part. And on top we have a crane to put them out. Yeah, there's another one, and it's open. The digester is rectangular. It's open, like we've seen in the very beginning on the drawing. I'm not sure you can step down. Go down the stairs, please. Then we'll find some pumps to manage the substrate. One pump is to feed the dewatering, the separator, and the other is for the heating circle. There's a small chopper installed. If the fibers, while heating, say we pump it to be heated, and if we pump it, we chop it the fibers to smaller parts and we can able to take out more biogas. I've seen this installation on the Energy Week in India, in New Delhi. It was a company. No one was interested in this kind of equipment. I told the sellers on site, because they were a little bit sad, that people will learn that they will need it on site, this equipment. So it only takes a few years and then they will be busy. This equipment is needed if you handle with solids on site.
Guys,
Just let me
take you.
save, please.
Somebody just asks for us to showcase the digester output input inlet to SLS, if there is such a thing possible right now.
I'm not sure about the question. Can you repeat it, please?
Showcase the digester output input inlet to SLS.
The dewatering system, the solid liquid.
Ah,
Where can we find
dewatering system, you have to go to the first floor somehow.
Okay, if it's not possible, then we can skip that.
Yeah,
I think it's
it
possible.
must be somewhere, because dry substrate after digester falls out on the right side. So if you go up the stairs, upstairs.
Okay,
this-
just a second. Just a second, going upstairs. But also what we could do is we could keep these questions and maybe take photos. I can document it later and also send it over so that there's clarity.
Yes, that sounds good. I just saw a very specific request regarding the site, so that's why I shared it. But yeah, do it only if it's easy enough.
Okay. We are walking up to the first floor. Hello. And we want to see the inlet SS. What was it?
The dewatering was required, I guess.
Output, input, inlet to SLS.
So if you go to the end, yeah, then to the right, there must. So on the right side in the red building, there's the gas holder inside.
Solid liquid separator.
Yeah, it should be. If you turn to the right now, there's a door, and inside there's a dewatering unit. On the right side, we have the over and under pressure valve for the digester.
Hello.
Here you can see the dewatering units. So it's screw press. It's a little bit tricky to install because the content from the digester is producing biogas in the digester, and it produces biogas in the pipes as well. And it produces biogas in the liquid after dewatering as well. So you have to avoid gas bubbles inside the pipes and the pumps. So you have to get rid of them. And it depends on what you are what you have as a feedstock from how much dewatering units you will need. So this is design. And if we build different digester, we have different dewatering units because the bacteria are all different. If you have 4 digesters, you will have 4 different population inside the digester. They split. One get Chinese, one Indian, one European. So they have different feedstock and they develop a little bit different. End product is the same. It's biogas, but the bacteria, even if you try to run them on the same temperature, they will develop in a different way. So it's very important if you do dewatering that you use the same recirculant from the dewatering unit. There's an overpressure valve. So this is not that easy to understand. On the left side, there's a gas getting out from the digester. And behind this wall, there we have a gas holder. And so the biogas is going into the gas holder. And then the right side, it's a overpressure valve for the gas holder to avoid that if pressure is getting too high, that it exhales, yes. And this piping is coming down from the pumps in the pumping room and feeds the dewatering unit. So even after decades, it's quite clear. It looks good to me. So these are external storages for biogas. It's a double membrane system because we have snow and rain. And it's the outer part, the gray part you can see is in this shape all over the year. And inside we have a second foil, and this moves up and down depending on how much biogas is stored. And in this case, we have a combination from liquid storage and gas holder. I'm not really 100% convinced of this system. I like it more if gas holder is external and tanks is extra, so it's extra system. It's more safe to run, to operate. This is a agitator. You can see on the right side, the blue one. Manchi, yep. This is a propeller, not submersive. It's a propeller mixer, and we use it here because it's all dewatered. There's no fibers inside. Everything we store inside this digester is dewatered before. It's very important to avoid floating parts, scum, and sediments. And here you can see the storage for liquids after dewatering. It's in use since the very beginning. Now it's September. Now they're harvesting maize and grain. And after the season, they truck all the digestate on the fields. And then it will be empty in the autumn, and over the year, over winter time, it will fill up until March, April, and then we use it again as a digestate, as a fertilizer, sorry. Yeah.
I guess that's
I
all,
guess-
right, Klaus?
Yep. Yeah, we have a CHP. It's an engine, but in India, you want to produce CNG, CBG, compressed gas. So we use it for electricity. It's an engine with a generator, and it's inside. I don't know whether we need to show it.
Okay.
Himanshi,
Maybe we can.
Can you show the substrate? If you can just close up.
So this equipment is for drying, to use the heat. We get additional subsidies, additional money for the electricity if the heat is being used.
Is there anything else that I can go to?
Not yet. Biogas is not that complicated. We've seen everything: dosing feeder, digester.
Any reason why there's sawdust there? Wooden sawdust?
This is for drying. So we get it wet, and if you want to burn this wooden parts to produce heat, it's better if it's dried. So it's an area with underfloor heating, and this warm air is pressed through this wood, and then it's getting drier and drier. And if it's already dried, then we can sell it for more money per ton, and because you can use it as as dried wood, and then you can burn it in the oven. This is actually nothing to do with biogas. It's only a possibility to use the heat from the CHP.
Okay.
Himanshi, if you can go to the substrate, the closest, I think we can close it.
The substrate, which part of it? The one that's coming out?
You know, not coming out. The one which is going inside. Do you have anything close by?
It's a long way to go to the beginning. Yeah.
Yeah, I have to go there to the corner. Maybe you can start
Maybe
your
we
question
can-
answer.
Yes,
Darshini.
let's move on, and maybe I will just give me a
No,
moment.
you can see the torch. Where if CHP is not running, we don't want to pollute the environment with biogas, because it has a big impact on the environment. So we need to burn it. We want to burn it, but it's only for emergency case, not emergency. But if CHP is not running, we burn it.
So with the site